All right, I'd like to thank everybody once again for showing up to another SLG Azure Fridays event. Before we get started, I do have a quick thing that I want to kind of highlight here, and this is our upcoming events. On November 10th, we're going to be doing a What is my cost to move to the cloud? This is really talking about a tool to analyze your infrastructure and things that are running in your data center, and to be able to provide you good insight into what the cost would be to take certain workloads and bring them into the cloud, to see what kind of cost savings you might have. And it also helps you identify those workloads that might be easier to move than others. So it's a really great technology. And so Steve Reed on November 10th is going to be presenting that. On November 17th, this one's really, really cool. David Golub from our data and analytics team is going to be doing a Parks and Recreation Save Our Trees presentation. And I don't want to spoil it for you, but very, very cool use of cognitive services and image analysis to help identify beetles which are damaging trees through many different parks environments. So really cool demonstration on November 17th. And then on November 24th, we're actually going to take that Friday off because of the holidays and stuff. We're going to go ahead and skip that one. And then we'll pick back up in December. Once again, all of our events start at 1:30 Eastern Time, and you can register at the same site that you registered for this event. And all of our on-demand recordings are made available at that URL listed there, aka.ms/SLG Azure Fridays. You'll be able to go out there, see a list of all of the past events, and to be able to just click through and watch those videos. Now, this video that's being recorded today will be made available sometime early next week, is usually what we target, early to mid of the following week to get these posted. So with that being said, I'll go ahead and turn it over to our presenter today, Justin from Netrix. He's going to be talking about Service Fabric and microservices. So with that, Justin, it's all yours.
Thanks, Mike. All right. As Mike said, my name is Justin Patton. I'm a technical excellence lead for Netrix. I am also a Microsoft partner cloud solution architect and P-seller as well. Let's take a look at what we will be going through today. We're going to do a brief introduction just in case people aren't familiar with Netrix as a whole and what we do specifically, my practice inside of Netrix. We will take a look at Azure Service Fabric from a high level, kind of what it's capable of, different use cases for it. Then we will deep dive a little bit into different application and service types that you can run within a Service Fabric cluster. Briefly discuss the application upgrade process and some of the health check failovers that are built in. And then we'll kind of circle back on that original question that was part of the presentation for today. Should we stick with traditional monolithic? Should we go microservices? What is maybe the best approach? We'll round out with that. So to start, just wanted to do a real brief introduction about Netrix. Netrix as a whole is kind of a full suite of offerings that we have, not just custom application development, but we also do network infrastructure, security, EMS, OMS, those types of things in the Microsoft space. So as you know, you're listening to the presentation today, just kind of keep that in mind. If there's other needs that maybe we could help you with, we are a little bit different maybe than your traditional custom application development shops where that may be all they do. We kind of have a full suite of products that we can offer for you guys, which really comes in handy in the Azure space, because like I said, my practice knows a lot about the custom app dev, and then we have teams that do a lot with security or VPNs or governance. We can kind of cover the entire realm under our one umbrella. So specifically what my practice does, we do specialize in Azure-based solutions, not just greenfield development, but also kind of that modernization of legacy enterprise applications is something we're starting to do a lot of, and that's actually where we're leveraging Service Fabric quite a bit to get those up and running. One of the main things that we always tell our customers about, it's not just what we can do, but it's how we do it. It's our process. So it isn't just you come to us with a need, we just look at that, check off the boxes, and go on our way. It is kind of this cyclical process of the different bullet points that you see on the screen here, that we do try to look at it from all angles and really evaluate what your business needs, and how we can best leverage the cloud and other platforms, and not just look at maybe what your very specific need was. Again, just wanted to do a real high-level overview of Netrix and what we could do for you. Would love to talk more after the presentation if that's something that interests you. But we are all here today to learn a little bit more about Azure Service Fabric. So let's get started with that. So overall, Azure Service Fabric is an integrated platform that allows you to build, deploy, and operate applications. Here's one of the big parts for me, is using any operating system at any scale on any cloud. So on the build side of things, like I mentioned, we can do a new greenfield application, or we can transform an existing legacy application and make it easily run inside of Service Fabric. The deployment of Service Fabric really is no different than deployment of other things you've done today. You can deploy things through Visual Studio Team Services. You can deploy it directly through Visual Studio. Any of the other various command line tools are available as well. So again, not a large learning curve to get to the deployment portion of Service Fabric. And then operate. Kind of at its core, it still runs on top of operating systems that you know, so those can be monitored and managed the way they've been done in the past. You can also scale them the way you scale virtual machines in Azure. So again, we're not doing anything really specialized with Service Fabric yet. That would be an additional learning curve for you to build on top of. So what does that look like as far as individual bullet points and a little more details on those? One thing that's really nice about Service Fabric is that it does run anywhere. You'll see different points on the screen about it running on your dev machine. So when I'm actually developing Service Fabric applications locally, it does start up a Service Fabric cluster and a single node if you want, or up to 3 nodes, and runs it as if it would be running out in Azure. You could also run Service Fabric in any other private cloud you want, or in a on-premise infrastructure. If you wanted to run Service Fabric in Amazon, you can do that. That's the way it's built, and Service Fabric is a free downloadable tool. You don't have to pay additional licensing costs to run Service Fabric. So within the Service Fabric landscape, different things that you can leverage to really kind of supercharge your application, especially from the programming and DevOps tooling side. There's a concept of reliable actors and reliable services. Those are native applications inside of Service Fabric. We'll talk a little more about those later and some of the additional capabilities of those. But that's what you usually target if you're doing a greenfield development or transforming an old application. Those two really leverage all the capabilities that Service Fabric has to offer. Outside of that, you can definitely take just a standard executable you have today and publish that and have it run inside of Service Fabric. You can also run different containers inside of Service Fabric. So it's not just something where you have to build it brand new. You can take existing functionality and applications that you have and deploy them to Service Fabric. And like I mentioned on the deploy side of things before, there's built-in integrations with Visual Studio, Team Services, Eclipse, Jenkins, all those things that people are used to using to deploy and upgrade all the Service Fabric applications. From a deployment standpoint, continuous integration and deployment obviously are supported. Docker Compose if you choose to run containers inside of Service Fabric, and then all the automation that goes along with the CI/CD pipeline. A lot of people like using PowerShell, and now PowerShell is available in the Azure portal as well, so it's being used even more. There are Service Fabric commandlets to control things from inside of there. Rolling upgrades and the monitor and diagnosing we'll talk about more later. But in essence, it's trying to ensure that any new packages that you deploy are healthy and leaves your application in a good running state. So we'll talk to that a little bit later. I'll demo kind of what the rolling upgrade looks like and how you can monitor that. But just know that this isn't just another kind of basic orchestrator. There are health checks and diagnosis capabilities built in that you kind of get for free as soon as you use Service Fabric. On top of that, always on availability. We'll talk later about different durability tiers in Azure. If you have 3 nodes running, 5 nodes running, and they all talk to each other. And when you develop your new application, you say how many copies of each service do you want running, how many copies of the data do you want in place. And Service Fabric just natively handles that under the hood without you having to do anything. Also to support scaling programmatically, so if you want to do that by yourself from the command line, but you can also set up rules within the Azure portal that stands those things up. It is secure. You can secure your Service Fabric cluster by using Azure Active Directory from an external facing aspect, and we'll show you what the dashboard for that looks like here in a little bit. But it also secures communications between the different nodes, so you're not worried about any sort of attacks on that side of things. One of the interesting pieces about Service Fabric to me is that this was kind of born out of Microsoft. So all the things you see on your screen right now are platforms that run on top of Service Fabric. So if you're running SQL Azure, under the hood on that, it's actually running on top of Service Fabric. Same thing with Cosmos DB, IoT Hub, and the rest of the things that are on there. So again, you're using a proven platform that Microsoft and even you use on a daily basis without even realizing it. So why would we go with a microservices approach? This comes from Cesar. This is actually a pretty good full write-up if you get a chance to review the link that was on the slide here. In essence, what we're trying to do with microservices is get away from the traditional monolith where maybe you changed one thing in the service, but now instead of just making an update to that one little piece and deploying that, you're having to redeploy the entire application. For smaller systems, that may not have been as big of a problem, but when you get into large, complex, data-driven systems, to republish an entire application can take a long time and also can be fragile depending on where you're making the change. So by doing things in microservices, we're splitting them up, and you're kind of reducing any headache when you make a change in service A that you may break something in service B. Still obviously a potential, but since you've broken these down, you have greater control and less likelihood of something going wrong inside of it. So what does a microservice architecture look like? Just in case you aren't familiar with it, this particular example is showing as if it was running inside of a Docker host, but from Service Fabric, it's really no different. In the past, maybe you had this traditional web app MVC that was sitting there, and instead of all of these other services being independent, they were just kind of all living inside of the same memory space and didn't do things differently at all. Now, by putting everything behind microservices, you kind of split up the responsibility, very similar to what you do with standard services and domain models in the past. But now you can deploy them independently. They all work independently. A key part of microservices that people sometimes miss is that they also store their data independently. So if I'm going to make a schema change to the database on the ordering microservice, the catalog microservice doesn't really care about that schema change because the contract with the ordering API hasn't changed. So all the data structures, if you will, can change. As long as the outlying API doesn't change, everything else operates just fine. When you get into a microservice architecture, it is really important to have a good analytics and reporting tool available as a part of that. So whether you use Event Bus, as it talks about here in this slide, and have kind of a central data repository where everything somehow gets written back to, or you can utilize a tool like Power BI that actually understands how to talk to SQL Server, Cosmos DB, these different types of storage, and you can just aggregate them all that way. But it is definitely a different way of thinking when you not only are splitting your services up, but now your data is also living in multiple locations and maybe different types of data. So relational in a SQL Server sense, or NoSQL in a Cosmos or MongoDB sense. So definitely introduces more complexities into the architecture, which definitely feeds into our two microservice or monolithic question that we will circle on later. So what does this look like from a cluster standpoint? Let's advance my slides here so we can watch some things move around. You can have multiple applications deployed to a Service Fabric cluster. And just because they're registered on the cluster doesn't mean they have to be running. You could have one on standby if you wanted to. You could have one that maybe you just provision to do some tests and then you decommission. But there is a concept of just registering them within the cluster. And then from that point forward, you're kind of just constrained by the resources that you have given to your various nodes that live inside the cluster. And as you can see on here, we have application 1 running on some, application 2 on some of them, and their scale and where the different services live are completely dependent on how that package was built. So if you had your red service on application 1 that you really need it on all 6, you just change that in the configuration and it goes to all 6. You can also scale it up through configuration changes in PowerShell, but you can easily configure what goes where, and you're not stuck with, oh, I need one new red service, I need to add an entire new VM. You can just move where that one goes. Like we mentioned before, different things you can host inside of Service Fabric. Just wanted to point out some of the differences depending on what you choose to do. So if you use a guest executable, so maybe an existing application, or if you're going to put a container in there, you can run it natively, but you don't get some of the benefits, communicating between nodes, using stateful dictionaries and things like that. So if you want to leverage those, you have to do it through the Service Fabric REST API. However, if you write a new service or if you convert an existing one over into a reliable service, then there are SDKs available that offer the various features that are mentioned here: health checking, reliable collections, different metrics, actor services, easy ways of talking between the various services on different nodes. So while you can run things as a guest executable or in a container, I highly recommend that if it's possible to move those all inside of a reliable service so that you can really leverage what Service Fabric has to offer. So let's do a quick demo here and just show you what Service Fabric looks like inside of Azure as far as how you would make a new cluster, what some of the pieces look like, and then I'll also show you what the basic dashboard looks like before we deploy an application to it. So here I'm inside my portal. To make a new Service Fabric cluster, fairly straightforward, just like everything else in here. We can go into the marketplace and we can find Service Fabric cluster and we can say create. The one thing I will mention is usually you'll want to secure your Service Fabric cluster. And in order to do that, you need to do that with Azure Active Directory. There is some pre-configuration and setup that needs to happen prior to creating the Service Fabric cluster. So as I'm going through some of these screens, I'm just going to bypass it and fake as if I would create it without the authentication. But most times you're going to want to have that. The thing to note with the authentication is you can't change it later on. So if you know you're going to want it to be secure, you need to spend the extra time up front and get all the different certificates in place that it asks for. Otherwise, you'll have to destroy the cluster and rebuild it later. Let's just put some items in here just to get it to go through. I have a cluster already up and running. I just wanted to show some of the things that it's going to be asking for. Again, creating the cluster is no different than other things you've created in Azure before, just wizard driven. So node types, I've briefly been mentioning the word node and I can describe it a little bit better. So you can have different size virtual machines inside of the cluster. Maybe you have some service that's going to be real memory intensive and you want to use higher memory VMs. You can make 2 different node types. So maybe you're not standing up 5 of these really big memory VMs, you only have 3 of them. So you can split things up that way. For demonstration purposes, I'm just going to say we only have 1 node type. We can name it whatever. So the durability tier essentially determines how many VMs you want to have, and based on the tier, what different size VMs you can use too. So it runs the full gamut depending on the tier you pick. I'm just going to select a default one here just to move things along. If you're doing this just for test purposes, you can definitely choose a single node cluster, but that's maybe just if you're playing around with it a little bit. Custom endpoints, by default, nothing can really come in and talk to various services within Service Fabric. So in the example I'm going to show you guys today, my website is actually running on port 8081. So I had to specify that in here so that it puts holes in the firewall. You can always come back in later and put holes in the load balancer if you want. This just makes it easy, so it's right here for you. So this is what I mentioned before, the security mode of the cluster. So you have to give it a key vault, the certificate URL, and the thumbprint. There are documents from Microsoft that walk you through here's how to get these different things step by step. They actually even provide some PowerShell scripts to do it for you. So again, if you're going to secure it, which we highly recommend, you want to do those steps prior to coming in here and configuring this. I'm just going to say unsecure for now. I'm not going to tell it to create, but it'll run some final validation and it'll go out and create the cluster for you. So it takes a little bit of time, which is why I'm not going to do it here. It has to create the virtual machines. In this case, I left it as 5. It has to install the Service Fabric SDK, all the running elements, and get everything ready. So prior to today, I had one that I created, and we'll just take a look at what that looks like. So this is the Azure view of the Service Fabric cluster. It shows the 5 nodes that I had running, shows the type of all of them, the health state, status, the fault domains that they're in. Other things you can do inside of here is look at the type of the node, the different endpoints that it has. If I had any applications deployed to it, we'd be able to see those through here. Fabric upgrades is another one to kind of think about. Some people like to leave the upgrade as automatic. Some people want to do it manually. This is kind of back to the whole Windows update thing. Do you want Windows updates to automatically apply, or would you rather choose to upgrade them yourself? The default is automatic. If you set it to manual, that's fine. But certain versions do start to get sunsetted, if you will, so you're responsible to come in here and upgrade them manually. Right now, there is no expiration for this version, so that's not really a concern, but it is something to think about. Directly from the overview, it does provide you with a link to the Service Fabric Explorer, which as you're looking through documentation about Service Fabric, is probably one of the common dashboards you'll see. Just look at this quick before we move on. So this is the dashboard for Service Fabric. When you're setting up security, that security is what's stood up in front of this portal. The security also stops people from publishing or attaching remotely to debug things inside of Service Fabric. Right now, this is just kind of sitting here open because I didn't need to secure it for any reason. It gives you an overview of your nodes. I have 5, they're all healthy. I have no applications that are running on here right now. So this will become more that we can look through once we actually publish an application to here. I'll show you the nodes, what's running on them. Again, once we deploy things, it'll all be on here. And this is no different before to my comment about whether you run it locally from a development standpoint. If I debug a service application locally, I get this exact same dashboard. So it's nice to have a consistent experience throughout everything that I'm doing inside of Service Fabric. All right, so different applications and services inside of Service Fabric. So now we're talking about those native services that run inside of Service Fabric. The first one we're going to touch on is called the Stateless Service. Hopefully is fairly self-explanatory. The easiest example I can give of a stateless web service or stateless service is a web application, whether that be just an API or something that's actually serving up web pages. Those usually are stateless. They, more often than not, will call into a stateless middle tier that is doing some computing, things of that nature, or maybe they're using it as their cache, which is on here too. So what you can do, maybe instead of offloading to a stateless middle tier, you're storing some of your items you want directly in a Redis cache. What we also get with this is that the front end, say we want to create a new item on our website. The front end can just send off a message to a queue, and then the middle tier is watching that queue and processing any requests that come through there. No longer are we sending a web request and making it hang around and wait for everything to happen. We can offload that to some other pieces. So Stateless Services is probably fairly close to what a lot of people are familiar with today. You can store some things in memory on those if you wanted to, but again, it goes away if the node goes down and moves somewhere else. That information is lost. So Stateless Service usually are kind of like the processing, if you will, where they don't need to store the data. They just need to take something in and move it along. So how does communication work with Stateless Services? Since they are stateless, no matter how many copies of them you have, they are the same on all nodes. So, and this is why this is a great example of a web application or a web API, is that if I have 5 nodes running in the cluster, I'm probably going to at least want that running on 2 for redundancy standpoint. Often we'll have some form of state if it needs to support kind of those fast lookups of data. And then just some other examples here too about gateways and things of that nature. So Stateful Services is where you can really start to leverage some of the benefits of Service Fabric. So in this scenario, we still have our stateless front end that's sitting out there, but now we have the stateful middle tier. And what that allows you to do is, instead of storing your data off in a SQL server or Redis, you're actually storing the data local on the hard drive of the different nodes. And then it gets replicated between different nodes, so it's always there and backed up. And what does that give you is now we're not doing the extra network hop to go to SQL Server or to call a different API. Our reads and writes are local to our disk, and then Service Fabric handles the replication of that data. Everything is handled with transactions, so you can lock as you're committing, lock as you're reading, do kind of the atomic read writes that we would want to do. But this is data that maybe you don't need to report on, but you're just storing it for a little bit of time. So maybe a shopping cart for Amazon or something like that would be a great thing to store in state. You start up an actor, which is just a single shopping cart, and if they empty their cart, you just get rid of that state, and you've never actually stored it in a database. Or if you complete the order, then that data goes to your ordering service, and we still get rid of the local state that's on there. So it's kind of an intermediate data store, if you will. And then, like this mentions, if you do get to a certain point that you want to actually have that for reporting or other availability, you can. But there definitely is a great benefit to having that information local on the nodes if you need it. Stateful Service Communication is kind of similar to the stateless. Most of the time, Stateful Services are kind of behind the scenes, and there's no direct interface from the outside world into them. So one of the things that it's showing here is talking to a naming service, which is tied into a reverse proxy, which we will talk about in a couple of slides. But the problem with Stateful Service is that you don't know which node that is running at any given time. So Service Fabric knows how to do that. So you have to go through the proxy to find out where you should actually go. And again, built into the SDK, if you're trying to talk from your web service to your shopping cart service, it handles all that for you. You just say, give me a copy of the shopping cart service, and this is who I'm looking for, and it figures all that out for you. And we'll show that here in code in a few minutes. So in Stateful Microservices, what does this look like? We can have persisted state across different nodes. And as you write via those transactions down to state, it replicates that data to other nodes. So in this case, the P is standing for your primary service, and the S is the secondaries. So when we talk later about fault domains and rolling upgrades and when things go down, if you happen to lose your primary, one of your secondaries just activates as primary and goes on its way as if nothing happened, because it has a copy of all the replicated state that it needed. Yeah, this is all happens under the hood. You do one extra call with the SDK, and you just get all this functionality right out of it. So like I just mentioned, there is a reverse proxy that you can turn on inside of Service Fabric that if you would ever want to access some of the stateful services and things of that nature that maybe you don't know the exact address for, you can turn that on and go through there. Most of the applications that I've written, we kind of just have a public-facing either web interface or web API, and then we have to go through there to get to all of our back-end services. So this is more, as needed if you can find a good use case for it. Otherwise, we tend to keep the other services kind of hidden behind our main API service. So let's take a look at an ASP.NET application inside a service fabric. For the purpose of our presentation today, I grabbed just a sample, which is a fairly simple inventory system with a shopping cart that sits in front of it. So I'm just going to briefly show you some of the things in the code that we've talked about, and then we'll also publish it to Service Fabric so you can see how it works. So this is an application that is made up of several stateful services as well as a stateless web service, and it also has actors inside of it. So most people are familiar with MVC controllers, so I'll just show you how some of these are hooked up. So here's an inventory controller that accepts a post message, and this is to create an item in the inventory. So we talked before about how you can easily communicate from one service in Service Fabric to another. That is what this service proxy is in charge of. So we have defined an inventory service with this interface, and we are using the service proxy to essentially create an access point to it, a web call to it, if you will. So using this inventory item, we are able to tell what partition key it's in. Partition keys can be a number of things. I often use GUIDs for partition keys, but you can also customize your own, which is what they've done in this example, as they have this inventory ID, which is a customized key that it can use to pull the information out. So you use the service proxy to create a client, essentially, to talk to that service, and then you just call the method on that client, and Service Fabric under the hood does all the logic to find on which node that's hosted and get the message delivered there and return any response back to you. The way actors work, if you're not familiar with the actor pattern, if you try to talk to an actor and maybe it's turned off because they're only up and running for so long if they're not in use, when you call a method on that client, it'll start the actor up, get it ready, and then execute the request against it. So if we briefly just look at this, and tell it to go to the implementation. Now we are over in the actual implementation of the inventory service, which is a stateful service. And you can see here, we're starting to use reliable dictionaries and reliable collections, which are things that we've talked about already today, where it is trying to get this reliable dictionary out of the state. It's creating a new transaction, and it's adding these items in and then committing it. There's also the service event source here that's writing events out. You can have this event source tied to application insights, and you can review all the events that are there. You can also do streaming traces directly through Visual Studio, so you can watch it as these things happen. Just one of the many ways you can monitor what's going on inside of your application. The main Service Fabric publishing piece is this application down at the bottom. It's essentially a lot of configuration. So we have an application package root, and I won't go through this in detail, but it essentially defines all of the applications or all the packages that we want to have running inside of our application, how many partitions they should have, how many should we replicate, and all that redundancy purposes. And then the nice thing you can do with publishing profiles is we could actually override some of these different values. So maybe when you're running locally and it's in one node, like this is showing we only want one partition to run. But then when we go out to the cloud, we want to run 9. So this is how you leverage connection strings. Maybe when you're in dev mode, you connect to one SQL server, but when you're in production, you connect to another. You use these publish profiles to overwrite it. It's very similar to web config transforms of the past that you can use these items for. As far as publishing, out to Service Fabric. Let's try to do that. As I mentioned before, we can just come right from inside Visual Studio, right-click and say Publish. And I have already logged in with my credentials prior, so that's why this is showing up here. Otherwise, if you haven't, you log in with the account that has access to Azure. It'll find any existing Service Fabric clusters that you have up and running, and it'll show them in the drop-down here. And then you can make any additional configuration options that you would need to do. For now, we are just going to hit Publish. Any luck, this should not take too long. We will let it do its thing. And we'll start talking about upgrade while it's moving along. Essentially what this does, it builds the application and then it runs a series of PowerShell scripts to actually publish the application, which you can see, I don't know if I'll be able to zoom in on here, that it's running this deploy Fabric application. So again, before about the tooling, when you do it from Visual Studio Team Services, it runs this exact same PowerShell script. If you wanted to just build the package and then use Jenkins or some other automated task to publish it to Service Fabric, you can definitely do that. What it's in the process of right now is it's built the binary, it's copying up to the image store, and then it will register it, which actually just happened. So once this is registered, it'll actually start to provision the endpoint. So let's see if we have, so now back out in my cluster, we can see that under applications, I have this web reference application type. Version 1.01 is the one that I was currently deploying. And right now it is validating the package and computing checksums on it to make sure that it's good before it starts actually publishing it to all the nodes. So we will let this thing run and we will come back to it in a minute. Shouldn't take that much longer. I just, in the interest of everybody's time, we will move back to the PowerPoint and then come back and continue on with other demos too. So upgrade and failover. You may have noticed in some of the slides or in some of the screens that there was a concept of upgrade domains and fault domains. Hopefully not a foreign concept, but essentially it knows that when I'm upgrading upgrade domain 1, then 2 and 3 are still running, and it only allows one upgrade domain to be down at any time. So Service Fabric has a very similar concept. In a minute, once this is done deploying, I'll show you the website. We'll make a minor change to the application and redeploy it, and then we'll watch in the dashboard and you can see how it does this rolling upgrade. And as it needs to upgrade, it goes one by one by one. And the similar thing is true with machine failures, which we'll show. I'll turn one of the nodes off, and we'll see stuff move around. But in this case, we have all the applications running where we want them. We are going to lose one of the nodes in here, and what happens then is the applications that were running on that node get moved around. Again, transparent to you, nothing you have to do to control it. One of the nodes goes down, they move off. If a node comes back online, they will move back if they need to based on the policies that you have set up inside of there. So let's see if our application has deployed, and we can walk through all this. All right, so if we look in Visual Studio, see that it checked the statuses. So as you're publishing, it makes sure that everything is up and running, and we can see that publish succeeded, and the build was obviously successful as well. So now if we look at our dashboard, we can see the application running, we can see the application inside of it, and we can see the various service types that were published as a part of it. Beyond that, you can actually go down inside, and for this customer order, we had specified that we wanted 9 partitions across the 5 different nodes. So we can actually check the health of the 9 different partitions if we wanted to, and you can actually see which nodes they're running on. So I can tell on this one, my primary is on node number 4. So later, when we do a quick, here's how the fault domains work, I can reboot one of these nodes, and we should be able to see that the primary switches to one of the other one without us doing anything. So let's take a quick look at what the application looks like. And I just borrowed a sample, and it's not impressive, but it'll at least give us an idea of what we're looking at. So again, this is running on port 8081. So when I built my cluster, I had to open up the extra hole in the firewall for it. but not hard to do. So all I'm going to do here is copy the sample data they gave us, which will essentially inject some content, some items to buy into the portal. So again, what this is doing when I hit create inventory here, it's making an API call to our web service, which is then talking through our proxy to a different service inside a service fabric, and it's storing all this information in state. So it says our submission was true, so we should be able to go out to the root web page of this, and we should have an option to purchase various things that are inside of here. So here are the different things that we just put into the inventory. The skirt, trousers, and dress. We can say, let's pick some random numbers on these. And we can place our order. So right now it says that our order was submitted. So let's take a look at the code. And I just want to show you what this is doing. And when we check the order status again, I'll show you how this works. So when we submitted our order, it came through the controller and came into this method on the actor. So it set state to tell us that the order was submitted, and it set state with a list of items that we were ordering. Then what it did, this is actually a built-in function of the actor itself, it registered a reminder. So instead of having to start a new thread or a new task and tell it to sleep for 60 seconds and then start up and do something, there's a built-in functionality to actually register a reminder with Service Fabric. So this was telling it to fulfill the order. So when this process fires, it will come into a fulfill order process. And we've been hooked up to streaming events. You can see this as it's happening. And what this is doing, it's seeing what items were ordered. It's going into the inventory service. And then if we don't have enough items in inventory, it would set it as canceled. Otherwise, it removes it from inventory and then sets this to be completed. So if I get order status here, now we're in a ship status. Again, it's just stuff happening all in the background, running independent in a different service. From an upgrade perspective, fairly straightforward. Let's just make a simple change. And we'll just put admin portal v2 in there. Now when we do a publish, I just need to make sure that you are upgrading and that you're incrementing the version number. When you do things in Visual Studio Team Services, there are build steps to automate this process. But if we're doing it ourselves through Visual Studio, you either have to open up the XML file directly or come into this screen and do it from here. So we made that one simple change. Let's publish the application. And we will make sure this starts to publish, and then I will jump back to the dashboard of Service Fabric, and we'll see how it does the rolling upgrade. All right, so it says it's registering the type. So we should start to see on here that it's doing an upgrade. So right now we can see our status is upgrading. And as it gets far enough, we should start to see, there we go. So now they're seeing the upgrades in progress. We're going from 1.01 to 1.02, and it's currently only on the first node in our upgrade. So what will happen for now, if we go back to our root website, or the admin page, we still say admin portal, because we haven't quite got there yet. And we don't know which of the 5 nodes we're talking to because my web service is running on all 5. So it's just going to progress through these. And when it gets through all 5, we should be able to refresh our screen and then see the V2 sitting out there. Again, it's trying to do 0 downtime. It's doing health checks. So if I put something in my code that during a startup process now is throwing an exception and it just can't run and just keeps running into problems, it will actually roll the version back. There's a time delay between when it applies the upgrade to the first domain, it'll wait. I forgot what the default time is exactly, but there is a time period that it waits before it moves on to the next one to ensure that everything is healthy. So if the demo people are playing nice with us today, I should be able to refresh, and we should see admin portal v2 in here. And they're not playing nicely today. But we did see that we have upgraded from 1.01 to 1.02, and you can kind of see how it rolls through the process. As far as the failover is concerned, let's see if we can get this to trigger. Stateful Services do offer backup and recovery. I know that may be a concern that people had about using the stateful service and backing up locally. So there is a process to do that, and you can actually test data loss through PowerShell as well. But let's see if we can get one of these partitions to move around. So this one is running on, so the one that's not running on 0. So this one's running on node 4. So let's see if we can restart node 4, and let's see if the primary will move over to 2 or 3. And not something I would recommend doing regularly, but definitely to show off and ensure that things are running. Injecting some chaos into the system every once in a while is a good thing in development. So what we saw already down here, the side just hasn't updated because it's not on refresh, is that our primary is on 2 and our secondary is on 3 now, since 4 is gone. So again, without you having to do anything, it detected that, made another one a primary, and actually what it's doing right now, since we said we always want 3 copies, is it's bringing up a 3rd copy on another node, again, without you having to change anything or do anything about it. Then again, when the node comes back up, it may move some things there if it needs to based on how many copies of items it wants up and running. Otherwise, it'll just kind of sit as is, and then if stuff needs to move later due to other failures, it'll definitely do that as well. Okay, so back to kind of our original question. To Monolith or microservice? So kind of traditionally, everything was the single giant monolithic application. Then you may have taken that application, taken the executable as it was, put it inside a Docker container or anything of that nature. Then people often will bolt on microservices that know how to talk to and interact with that existing monolith. Then you take that original monolith and you start breaking it up into small pieces, and now you essentially have this whole new transformed app. We've actually seen that this flow is still beneficial today. There's anecdotal evidence going around that maybe even if you start out as a pure microservices app, it may not go as well as if you had started out with the monolith and slowly extracted pieces from it. Depending on the scale and the scope of the project we're doing, it does go one way or the other. But we're definitely seeing that. I mean, just because microservices and containers are the big words nowadays, traditional apps are definitely still there and should be used unless there's a real good use case to split things out into microservice. So different scenarios that are available, like I mentioned before, lift and shift containers, taking existing applications, taking those executables, publishing them up there and just letting them run. Anything mission critical because of the resiliency and the redundancy that's built in the service fabric. IoT data processing, any new native apps. I mean, I showed before what different things run on service fabric just from a Microsoft standpoint. They can all run on top of Windows servers. They can actually run on top of Linux containers now as well. So if you're more into that space, you can definitely do that. Here's a link to a Service Fabric quick start that you guys could use in the .NET Core space. Again, the slides will all be in the video afterwards, so we can click on that. But there are definitely tutorials all over the place, along with additional documentation that is provided in here. So there's Microsoft Virtual Academy, courses and labs. There's various samples, IoT solutions, Some of the things we've started to offer as Netrix is actually workshops. We'll do hackathons, whiteboarding sessions around Service Fabric and other things in Azure that are definitely a possibility as well. Thank you for everybody for listening today. I'm just going to take a quick look through the conversation. I think Mike's been handling a lot of the question as we went along. Mike, I don't know if there's any of them that you haven't covered that I need to touch on.
Just the last one. So API management, working with Service Fabric, is it just a matter of putting them on the same VNet? So I will say, from my opinion, it actually doesn't even need to be on the same VNet, to be honest with you, because really you just need that the ability for API management to be able to reach the endpoint. So if you want it on the private side, same VNet would be helpful. But if your Service Fabric endpoints are public, then it doesn't really matter from an API management perspective.
Correct. Yeah. If you didn't want your API to be publicly accessible, then yes, you'd want them on the same VNet. But otherwise, yeah, Mike, you're correct.
Yep.
And then just one note, because I saw the one about publishing the whole project. In that scenario, if you wanted to publish just one microservice or upgrade one instead of all of them, you would just end up having a different publishing project for each individual one. It's kind of, do you want to publish the whole or the pieces? So we would just need to stand up an additional publishing project essentially for the individual services to deploy them that way.
And I believe, Justin, if you kept it the same way that you did, but just didn't change the version numbers for the items, then the upgrade process wouldn't occur on the ones where the version number didn't increment, if I'm correct.
Haven't tried it that way, but that could be possible. Sometimes it looks at the code package dates and things like that, and it may see that it rebuilt.
Yep, the version.
And sometimes it complains that the version already exists.
That's true.
So often when we do it, we'll split them into different publishing packages, and then you can kind of pick which deployments you want to run.
That's probably a good best practice, actually. So
okay, well, that is all I had. I said my contact information is on the first slide. Definitely feel free to reach out to me if you have additional questions, or Mike as well.
Yeah, and so thank you very much, Justin. This was an awesome presentation, awesome demo. Really appreciate that. I think we had some really good questions this time around. So once again, this happens every Friday. We have different events, different topics. So please go out to the slgevents.azurewebsites.net site to register for those. This recording will be made available early next week. Once again, it's aka.ms/SLG Azure Fridays is the link. Or if you go out to the events registration site, up at the top, there's a prior events link. Click on that. That'll take you right on over there so you can see the ones that we've had in the past. So with that, I'm going to go ahead and stop the recording, and I'd like to thank Justin and Netrix for taking time to present with